Carbon dioxide emissions are one of the main causes of climate change, and researchers are trying to find ways to remove it from the atmosphere. That includes researchers from the National Institute of Standards and Technology, or NIST. Pamela Chu is a group leader in the Materials Measurement Laboratory at NIST. Pam, welcome to the program.
Thank you.
So first, explain this idea of direct air capture. How does it work?
So direct air capture is a technology that we're working on to remove carbon dioxide or greenhouse gas emissions from the atmosphere. One of the main challenges is that with human activity, a lot of these greenhouse gases and CO2 emissions have actually collected up in the atmosphere. That's one of the major drivers for climate change that we're experiencing now. And what we really would like to do is remove those emissions, and direct air capture is a way of doing it. Think of it like being a plant. We want to take the CO2 out, much like the plants do, and then we want to permanently store that CO2 someplace so that it no longer impacts our atmosphere.
But how do you actually grab it out of the air? Like, what do you use to take it out of the air?
So there are different solutions and materials that have been proven to take the CO2 out of the air. But one of the things that we're looking at is to develop better materials that do that process more efficiently and more effectively, so it takes less energy and less, and it'll cost less ultimately to do this process.
And obviously there would be a big benefit of taking that out of the air. It would alleviate some of the effects of climate change. What potential impact does this have if you're able to scale it?
So yes, hopefully we can scale it. One of the benefits is really to mitigate the climate change that we're seeing now, because we have a lot of CO2 up in the atmosphere, and that's what's impacting our climate today. As we go forward, we really need to mitigate these emissions, and so as we can scale it up, we can hopefully bring our environment back to before our emissions had such bad effect.
And what role does NIST play in all this? Why is the federal government involved in this?
So NIST is really has a very specific niche of developing measurement science. So a lot of the measurement science that we develop pushes measurements forward one step, two steps at a time in order to improve our understanding of how things work. And it helps spur on innovation and new technologies. An example is our push to develop better frequency and time measurements have really developed the global positioning system that we know today. So in the similar fashion, we are doing this for direct air capture. We're applying it to materials to understand how they might absorb CO2 and release that CO2 so that we can permanently store it, and so that hopefully we can spur on a new industry to effectively capture the carbon dioxide.
So Pam, what's the biggest challenge in actually getting this to work?
The biggest challenge really is to scale it up to a level that's effective and have impact. One of the challenges right now is there are prototype systems that are out there, but they're really only working at a level that's, we really need to improve it by 6 orders of magnitude.
So is this really going to work? Are you optimistic that you can make this work, that it can actually have an impact, and that you're not actually increasing carbon emissions in trying to get it to work?
So I'm an optimist. I'm hopeful that we can make it work. It will take some research and development to really push this technology forward. But examples of where we are today that we didn't anticipate being is where we are with solar energy and wind energy. You know, those are now economically viable. In the 70s, they weren't. So, you know, with time and with research, I think we can actually get to a point where this will be effective. We have a lot of bright people working on it, and it's really, it's an all-hands effort right now between industry and the government to try and make this work.
Tell me a little bit more about that and how you're working with industry and what their role is and what your specific role is.
So again, our specific role at NIST is to develop benchmark measurement science and benchmark materials to help people compare what they are achieving in the research and development. So essentially what we do is provide a ruler for this system, and so we can measure the success of new materials and new discoveries that other people are creating. And then industry, how we work with industry is really we work with convening stakeholders from industry and across government to understand what the problems might be and how our measurements and standards that we develop can actually help the adoption of these new capabilities. For example, in the cement area and concrete, those are one of the biggest emitters, CO2 emitters, a major emitter of CO2. And so what we're looking at is convening a consortium with industry and government to identify the challenges and the measurement challenges that are needed. You know, what we want to understand is the whole carbon footprint of this industry, and then be able to address it to reduce that carbon footprint.
Are you also collaborating with other agencies within the federal government?
Yes, we are looking to do that. You know, with our work in this consortium, we have a number of other agencies that are working with us. We also work with, attend a lot of the different agency meetings to discuss our progress and understand what is needed from their perspective.
Is this something that's going to require more than just NIST? Is this a whole of government kind of approach?
This is absolutely a whole of government approach, because there are all sorts of things that are needed to actually make this happen. We have to work on the science, we have to work on scaling it up and the engineering and the prototypes, and then we also have to work from the policy end to help spur that industry along.
Well, it's a big problem, but I'm glad that you're on it. Thank you so much, Pam, for coming in.
Thank you.
Thanks for watching. If you enjoyed the video, give it a thumbs up and subscribe to our channel so you don't miss out on any future Government Matters interviews.